Okay, so today we're gonna spend the day finishing our labs from that Egbert project, that lab sheet. And then we're gonna review for the test. There is just a couple I wanted to look at, and one of them being calculate Egbert's acceleration between meter 1 and 2 using the data, calculate Egbert's acceleration between meter 4 and 5 using the data chart. The process for these are going to be the same, so I just want to run through one of them. So I'm going to run through number 4 so you kind of have an idea how to do this. So we have done acceleration calculations. That's going to equal our speed final minus our speed initial divided by time. Okay. So when we do this, we're going from meter 1 to meter 2. So we need to find what our speed is for meter 1 and for meter 2. So remember our formula for speed. That equals our distance over our time. Okay, so we're gonna start, we start at time 0, we start at 0 meters. So that speed for that first meter, that's what we have to calculate first. Okay, so our speed for the first meter, we're gonna call that our speed initial, is going to equal, so let's find our variables. What's our distance? So it's going from 0 to 1 meter, so our distance is 1 meter. And our time, we go from 0 to 1.02 seconds. So our time is 1.02 seconds. So our speed is going to equal our distance over our time, which equals our 1 meter over our 1.02 seconds. And that is going to give us 0.98 meters per second. So this is our initial speed for our acceleration calculation, because that's our speed at that 1 meter mark. So now we need to find our speed final, which is going to be our speed at that 2 meter mark. Okay, so our speed final for our acceleration calculation is going to be our speed at that 2 meter mark. So we need to find our distance and our time. So our speed for this meter, we went from 1 meter to 2 meters. So this distance for just this portion is going to be 1 meter again. So 1 meter. Our time is going to equal this time minus that time. So 1.85 seconds minus 1.02 seconds. And we're going to get 0.83 seconds for our time. So our speed is going to equal our distance divided by our time, which equals our 1 meter divided by our 0.83 seconds. And we're going to get 1.204 meters per second. Okay, so now we have our speed initial and our speed final. Our time, since we went from 1 meter to 2 meter, we use this time change, which is the same as this. So for our acceleration one, we don't know what our acceleration is. Our speed initial is what we calculated up here, our 0.98 meters per second. Our speed final was what we calculated here for our second meter, 1.204 meters per second. And our time is going to be for that second meter, 0.83 seconds. So I'm going to write my formula. Then I'm just going to plug my numbers in. My speed final, 1.204 meters per second, minus my speed initial, 0.98 meters per second, divided by my time, 0.83 seconds. When I put that in my calculator, I get 1.33 meters per second squared. Okay, so we need to talk about significant figures. Since this is just giving us one number, my sig figs here is going to be one number. So my acceleration is going to be 1 meters per second squared. Be careful with that. That's something I probably will change on the test. So just make sure that you're doing the appropriate sig figs. So for a question like that, you got to have your variables for speed initial, your formula, your work, speed final, your formula, your work, acceleration, your variables, your formula, your work. So that test question, I need to see all this stuff, and that's it's going to be quite a few points. I believe it's about 10 points. Let's see here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 points. So that kind of a question is going to be worth 10 points on your test, which I'm going to tell you right now is probably a third or half of those points. The other one I wanted to talk about real quick is, let's see here, number 11. I don't give you any information, so I'm gonna just give you some. So try it with 156 grams for your mass, and that your acceleration is 9.8 meters per second squared. So this one, you would do your force equals my mass times my acceleration. Mass has to be in kilograms, so you're going to have to convert this to kilograms, which is 1, 2, 3 point. So that would be 0.156 grams times 9.8 meters per second squared. Put that in your calculator. I'm going to get 1.5288. I need two significant figures, so that's going to equal 1.5 newtons. Okay, so those are the two that I wanted to look at. Your test is going to be on Monday. You're going to be able to use your book and your notes. My recommendation is to go through every single one of these questions and get down an answer that you think is scientific. It uses your vocabulary terms. You're explaining what these things are and how they relate to our project or to real life, whatever that question is asking. And so be prepared to do your test on Monday.